constraint-based sketching, symmetric constraint. Let's start with the line. I have my automatic create constraint active. Let's have another line. Let's have a construction line, and I'm not going to draw it vertical. I'll draw it slightly off. Let's make these symmetric. Let's choose an axis of symmetry. Let's choose now, select two curves. So let's select this curve and this curve. So it jumped over like that. I've made a mistake. Let's move back up. I will now fix this line. I will choose my symmetric constraint, choose that to be the mirror line, choose my two lines. Here's my line to be changed, and here's my change to line. So what this now means is that if I move a curve end, the other curve end, or this one here in this case, is going to move with it, or the curve itself. So this is good for obviously length of lines and symmetry about this line. So in effect, it's a mirrored line. Think of it as a mirrored line. What else we can do? We can add a line, any angle. Let's go on to this symmetry line and have another line. So because now these are connected at this junction here, automatically with this coincident constraint, I'll just show you. Coincident constraint. Any change to this line will be reflected. In fact, it's not on the right place. There it is. So let's move this now. And you can see you've got this symmetry. Handy. Let's have, let me have a dimension between these two. And let's make this 65. You can see the other one is correspondingly changed. We have a length, 25. And I can move these, and as you can see, symmetry is maintained. I can add another angle. .45. So there's quite a few things you can do with the symmetric constraint. I think it's quite a handy and nifty constraint. Symmetric constraints are also implied with the use of mirror line. So if I can select this axis here as set as mirror line, now every time I create any line, any curve, we get the symmetric opposite about the line being created. So let's take a closer look at this symmetric constraint. If I click on the icon, I have 1, 2, 3 symmetric constraints. If I click on the curve itself and look at the delete menu, I have a curve constraint and 2 point constraints. So at the moment, it's those two lines are the same size, and the direction of the curve is reflected about the mirror line. If I go to my curve itself and right click and look at the options, let's now delete both points and see what happens. So although the curve itself is still being reflected about the mirror line in terms of its direction, the length of these lines is now not being controlled. As you can see, I can make them, as you can see, they're not connected any longer, but the actual direction is still being reflected. So now I'm going to add back a symmetric constraint between these two curves. If I go to the command, now I want to point out that we have this option here, make ends symmetric. So I'm going to leave that option ticked. Now before I do this, I'm going to quickly add a fixed constraint to just this curve end here. And now go to the symmetric constraint, make end symmetric, select an axis. Now select the target and select the anchor curve. And now those curves are perfectly symmetric. Now when I did that, with that anchor point there, it's been replicated with a fixed point up there on that curve. So we have perfect symmetry. If I delete this anchor point, and let's move that point. So there's curve end symmetry. So I hope that quick demonstration shows why we have three symmetric constraint tips, one for the curve direction and one each for each pair of endpoints.